Okay, so the topic is the derivative. We're going to run through a couple proofs, and I'm going to leave one for you as an assignment that you will hand in tomorrow, because it's just one question. Maybe I should make it two. Well, whatever. We'll see how it goes. All right, so derivative. So definition of derivative. It's basic stuff you know already from Cal 1. But I'm going to prove some stuff that we didn't prove before. So the first thing is definition of derivative. So based on the notes here, this should finish in one lecture. That should be good. All right. Let I be an interval. Let capital I be an interval. And let F be mapping from I to R be a function. So let I be an interval and let F mapping I to R be a function. Of course, know that the real numbers from the interval to the real number set, or set of real numbers. And let me say it again. Let I be an interval from I into R be a function. And let C be a number in that interval. Full stop. If the limit L, which is if the limit L, which is equal to the limit as as x tends to C, that's correct. So if the limit that I'm writing here, if the limit L equal everything here, exists. So if the limit L equal that limit you see there exists, then F is differentiable at C. Then F is differentiable at C, comma, L is the derivative of F at C. L is the derivative of F at C. And F prime of C is equal to L. The derivative of, that means the derivative of F at C is equal to L. So if the limit L equal to that limit right there exists, then F is differentiable at C, comma, L is the derivative of F at C, and F prime of C is equal to L. Stuff you already know, I hope. Bringing it back to your memory now, because we're going to be using it in our proofs today. All right. So given that we know that, I'm going to prove two rules for you. I'm going to prove the product rule and the power rule. Yes, power rule first. I'm going to prove the power rule. I'm going to prove the product rule. And I'm going to leave the quotient rule for you to prove as an assignment. And then I'll give you Rolle's theorem and then we'll leave it there. Wait, let me check if I need to go through the Rolle's theorem. I think it's optional. You know what? Not doing any optional stuff. Let's leave those two proofs. And you're going to prove the quotient rule as an assignment. which is due tomorrow. That's one question. And that's it. When did I say the next test? Did I say Wednesday or Monday? I don't remember. Or did we not say anything?
I didn't say anything about any next test, but we need another grade.
Right, that's why I want to give you one more test. I can put another, well, no, but I'll give you this question as an assignment. I think I'll give you the test. But anyway, proof. So first thing we're going to prove is the power rule. The power rule is pretty nice to prove, that is. So remember, the power rule says that the derivative of x to the n is equal to n times x to the n minus 1. So we're going to prove that using limits. I think I did it before for my calculus class, but not in detail. So I'm going to show you again now. All right, now the first thing you remember is the binomial theorem for the powers and the coefficients. For example, like x plus y to the nth power. We know it's equal to x to the n. It's going to be n times x to the n minus 1, oops, times y, plus, does anyone know what comes next? We know it's going to be x to the n minus 2, minus 2, and y to the 2. But what is multiplying it right here? What is multiplying it in front right here? Do you remember? Or do you remember how to find it? All right, you see, when you're pausing and you're not responding, I don't know if you're trying to figure it out or the answer is no. So if it's no, tell me no. Do you remember how to find it?
Sir, can you repeat, please?
I'm asking what is multiplying, Mikila doesn't remember. Okay, what is multiplying this thing right here? Yeah.
What is multiplying that thing?
So the coefficient of the x, this one is n, the coefficient right
Oh,
here is
n
1.
plus 1.
Right, so
N
let me put it
minus
over
1.
that is part of it. Right, so let me remind you. Each of the coefficients is going to be coming from this thing right here. N choose, well, call it, what do I call it? K. All right, hold on. Let me make it easier for you to remember. Let me give you a rule. X plus, write this down. If you don't remember it, write it down. It's useful. It's going to be important to prove other stuff as well. Is equal to the sum from k equals 0 up to n. That's an n, not h. I'm right to the brackets. Easier to write that way. Into the NCR or NCK. X to the n minus k times y to the k. Oh Lord. Sorry, this is x plus y to the, where did we get b from? This should be n. X plus y to the nth power. I don't know where the b come from. So make a note of that. So we've seen examples before, like when you have the fifth power, we know it's 1, 5, 10, 10, I think. 5, 1. Let me see, right. 1, 4, 6, 4. Oh, it's correct. 4 and 6, 10, 6 and 4. Okay, that's right. All right, so look, let's see if we can get it from this thing. X plus y to the fifth power. would be equal to, based on the summation, n C0, remember it starts from 0 right up to n. Why am I saying n? 5 C0, or 5, yeah, call it 5CR, or 5C0, x to the 5 minus 0, which is just 5, y to the 0, which of course is just 1. Plus, next we have 5C1, x to the 5 minus 1, y to the 1. Plus 5C2, x to the, you get the point right, the 3, and then y to the 2, and so forth. But you see that these work out because right here plus whatever comes next. It's going to go right up to 5C5, x to the 5 minus 5, y to the 5, which of course I know is just y to the 5. Because this first part here, 5, any number choose 0 is 1. And of course, y to the 0 is 1, so this is just x to the 5. 5C1, any number choose 1 is the number, so in this case it's 5. X to the 5 minus 1 is just x to the 4, and of course y to the 1 is y. So you see it works out. So please make a note of this and remember it. This thing I wrote in red at the top. That's why it's called the binomial theorem, binomial expansion. That's where it comes from. The Pascal's triangle was created afterward. After they figured out that there was there's a pattern here. The numbers just actually line up like that. So it's not the Pascal triangle that created the binomial expansion, it was the other way around. Mr. Pascal just saw the pattern. All right. Anyone writing anything? I'm going to go back to the question I asked. Well, I can write it down here. The question I asked was, if we have x plus y to the nth power, and we have, I think I already wrote out x to the n. I think I also wrote n times x to the n minus 1 times y. And I'm asking you, what comes next now? What's the term that comes after that? It's something times x to the n minus 2, y to the 2. What is that something? So use the formula now and see if you can figure it out. Ready now? What is it? Did you even try it, by the way? You're getting close, Lafern. You're missing one thing. Well, I suppose you don't know what you're missing. So let me write it out then. But Lafern, that was very close. All you're missing was the denominator. So it's n times n minus 1 over 2 times x to the, what did I say, n minus 2, y to the 2. And after that, you have, I'm just going to go right up to the n, plus, plus, plus. Actually, I'll put plus, plus, plus up here. Plus n, plus again, n times x, y to the n minus 1, plus y to the n. I'll skip out the middle terms, whatever they are. There's the next thing that comes after that, next term, but I'm going to show you how to get them properly, because you have to remember the formula now, the NCR formula, or NCX formula. So I'm going to show that to you, how we got this result right here, because you need to make sure you remember this. So take that off, something you should have seen, well, maybe not. Yeah, of course. That's in the next course before this, Cal 3 or Cal 4, Cal something. I don't know. Been a while since I taught those courses, I don't know where they are. But that should be somewhere. Is anyone still writing? No. All right. So the how we got the n minus 1 over 2. Remember, the formula is for NCX, the formula is n factorial over x factorial times n minus x factorial. So because a while ago we had NC2, right, or NR2. I think I wrote it like this, N2. Same thing. Both of these are the same. So, I should make a note of that right here. NX is the same as that. So because we were doing N2, N choose 2, NC2, it would have been like this now. It would have been, sorry, 5C2. No, it was N, You're right, it was N. So it would have been N factorial over 2 factorial times N minus 2 factorial. Remember, N factorial is going to be N times N minus 1 times N minus 2 times N minus 3 factorial. Put it like that, because I can't write anymore. It does N minus 1, N minus 2, N minus 3, you write down to 1. And below here we have 2 factorial is just 2. And you're going to have N minus 2, N minus 3 factorial. Because it's going to keep going down to right down to 1 as just like the one above. So it's N, because let's say N is 6. It's going to be 6 times 5 times 4 times 3 times 2 times 1. The same thing occurs with the N minus 2. It's going to be N minus 2, N minus 3 right down to 1. So what's going to happen is that these two are going to cancel. This one right here, that one right here, along with this extra N minus 2, this N minus 2. So left with N minus 1 over 2. So the only thing you forgot was the 2. So if I were marking your paper and left out that 2 alone, you only lose half mark because you left out a very small part of it, although it's important. But at least you show you knew what you were doing, but you just made a mistake. So you cancel the N minus 2's, Lafren, I forgot the 2. I'm hoping I did. Or you were swatting. Were you going from memory?
Sir, I canceled something. I'm not sure. I'm not really sure.
Maybe I cancelled the 2 as well. All right, no problem. At least you were on the right track. All right, so remember that this is not what we're studying. This is something you know already. What you're going to show now is proving the power rule. But you need to know that to prove the power rule. So I'm going to go as slowly as I can. Well, maybe that's not true. Can probably go slower, but I'm going to go slowly now. All right, so remember that rule that we just wrote a while ago? The x plus y to the n is equal to x to the n. Write them down again. X plus y to the n is x to the n plus n times x to the n minus 1, y, plus n minus 2 over 2, x to the n minus 2, y to the 2. And it's going to keep going in that order, where the n is, the power for the x is getting smaller, the power for the y is increasing. I'm using this thing right here, NCX, to figure out the coefficients of the terms that occur in that expansion. I'm going to write down to y to the n, of course. Anyway, so bear that in mind. We're going to use it now. So we're now going to prove the power rule. So the power rule, I wrote it before, let me write it again. It says that if f of x is equal to x to the n, then f prime of x, the derivative, is equal to n x to the n minus 1. Why is this so? So let's go back to our derivative formula. The formula for derivative is f prime of x is equal to the limit as x tends to c. Sorry, that should be f prime of c now. That's not the formula I was using. I was using the other formula. For the power rule, I need the other formula. The one I didn't write. The one with h tends to 0. Let me write it back. I didn't write this one. F prime of x is equal to the limit as h tends to 0 of f of x plus h minus f of x. So write this one down as well. This is the one used to prove the power rule. We could actually use the other one, you know. I'm not going to use both of them. They say that both of them can work. Why use this one first, since I wrote it down now? All right. So for this rule, We're going to put in the formulas now. We're going to put in our f of x. Remember, f of x in this case is this thing up here, x to the n. So that means that f prime of x will be equal to the limit as h tends to 0, x to the n plus h. Sorry, x to the h plus n. Because now we're going to put x plus h in place of the x up here. In place of this x right here, we're going to put x plus h. So that's going to be x plus h to the nth power minus f of x, which is just x to the n, all over h. So substituted in this formula right here, I replaced f of x with x to the n. And of course, for f of x plus h, you have to replace the x with x plus h. So I'm going to expand that now, based on the Pascal thing that we just did, the binomial expansion, binomial theorem. That's going to be limit as h tends to 0. So I'm going to expand that x plus h to the n. That's going to be x to the n plus n times x to the n minus 1, or h, I almost put y now, h, plus put 1 more, n times n minus 1 over 2 times x to the n minus 2, h to the 2. I don't need any extra terms. I'm going to put in the nx to the h, nx to the 1, h to the n minus 1. I skip some terms, plus the final term, which is h to the n, minus x to the n at the n. So all this that we just wrote a while ago is x plus h to the n. At the end now we have minus x to the n, based on this x to the n right here. That's what I just put in at the end. And that is all over h. All right, everybody should be okay so far. If not, stop me right now. So those two things are going to cancel. Which two things am I referring to? These two right here. This one at the front and this one at the end. The most extreme terms. And we're going to divide it by h. Because, in the interest of time, because I have little space, I'm just telling what is happening. Those two cancel. We're going to divide everything by h. So each term is going to lose an h. So we're going to get the limit as h tends to 0. N x, I'm going to need a big bracket here because there's no more denominator. It's divided out. Nx to the n minus 1 plus n minus 1, so minus 1, over 2 x n minus 2 h, because I divided out one of the h's, plus blah, 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 blah. Oh, by the way, the next term, someone ask about it, plus divided with the h here, so it's going to be nx to the h n minus 2, because I divided with one of the h's, plus h to the n minus 1, divided with the h again. That's it. Remember, divided out, so there's no h in the denominator. So now we can input all the zeros for the h's. So we're going to get nx to the n minus 1, there's no h here, plus it's going to be n minus 1 over 2 times x to the n minus 2, but times what? Times 0. Plus whole heap of zeros in here too, because all of them have h's. 0, 0, 0 in here everywhere. Right at the end we have 0 again, and then h to the whatever is 0 again. So the answer is just simply x, beg your pardon, n x to the n minus 1. That is the proof of the Power rule, or one of the proofs. I'm going to use the other formula as well. Wait, I can give a first assignment, you know. Oh, okay, I prove it. I took the question through. Yes, Anthony. Oh, you're here.
Yes, sir. Came in about 2 minutes ago. Sorry to be late. Okay. In terms of the substitution at the top at the beginning, where you have x plus h to be n if you want to call it n. Yeah, minus x to the n. I know when I just started learning this thing, it always give me problems in terms of that part. But I haven't done it in such a long time now, and I'm trying to figure out how do you actually make the substitution. That moving from the original.
From the function to that.
Yeah.
Alright, so I'll show it to you. When you finish writing, I'll show it to you. Because I'm going to use some examples to make you see it properly. So guys, let me know when you finish writing. There's 3 of you, so you can just type finish or say something when you finish.
You can go ahead, sir. I'm not sure who else is writing.
Alright. Lafern, are you finished yet?
Yes, sir, can go ahead.
Okay. Alright, so let me answer Anthony's question first. Alright, so remember the formula is f of x plus h minus f of x. Of course, the limit is at the front, but for what you are asking, we need to bother mention that. So all right, let me just put the limit. Blah, 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 blah. Now we have f prime of x to be equal to this, and you're given that f of x is equal to. Wait, your main concern was the x plus h to the n, right, Anthony?
Yes, sir.
Okay, let me just focus on that then. If you have f of x equals to say 6x plus, matter of fact, right, or we had f of x equal to x to the n. If I ask to find f of 4, you would say replace x with 4. Make sense so far, Anthony? Okay with that?
Yeah, man. I want to
If I say negative 3, you'd say, okay, replace x with negative 3. So if I say f of something, let's say a plus c, replace the x. Remember, still you're replacing this x. Same thing we did all along, replace that x, a plus c. Agree with that too?
Yes, sir.
So if it's x plus h, replace the x with x plus h. And the same thing each time.
Wait. Okay. So what you had before was x plus h in the bracket there?
Yeah.
Okay.
So all I do is replace the x, the same x underline up here with x plus h.
Okay.
There's the same substitution for each of them. If you say f of 4, you put the 4 with the x's. F of negative 3, put the negative 3 with the x's. X plus h, put the x plus h with the x's.
I'm trying to.
Same replacement.
I'm trying to recall exactly what was there. Can you write the entire thing? Which is
No
x?
problem.
Okay.
The formula was limit h tend to 0, f of x plus h minus f of x over h. And we're given f of x to be equal to x to the n. So you're going to make substitutions for each of them. So it's going to be limit h tend to 0. Replace the x with x plus h. Are you okay with it now?
Yeah. Right.
All right.
You're moving from the function form, which is the right hand side, to the left hand side.
Right.
Okay. Because at the top, what you have is just the left hand side where you have the f of whatever minus f of whatever. So now when you substitute it into the x to the n, the second part is
Yeah. That's what you use. Yeah.
thing. Okay. Got it. Thanks.
All right. So the other formula I gave you guys a while ago, before, I think Anthony didn't see that one. So I'm going to go back to that one now. The other formula, I'm going to prove it this one as well. So this is equal to the limit, this time as x tends to c. So both derivatives are the same, you know. Just start use different methods to get the same answer. X minus c. Of course, as you can see, in the same problem that we have with the limit as h tends to 0, if you put in the 0 for the h immediately, you get 0 over 0. If you put in the c right here, immediately you're going to get 0 over 0. So, you know, there's always some, what do you call it, some algebra you need to do first. So we're using the same power rule, proving the same power rule, I should say, not using, proving it, x to the n. Or should I show you something before this, you know? Most people probably don't know this. Honestly. I showed it to my college algebra class sometimes, but I don't know if you guys saw it, so let me show it to you. X to the Alright, it's the same thing I'm going to use, so let's use it. X to the n minus c to the n. We're gonna get that soon, but I want to make sure I tell you from now what it's equal to. I don't have to tell you, I can actually divide it and show it to you. No, I'll tell you. So, I have time for the divide right now. So this is the same as x minus c times x to the n minus 1 plus a times x to the n minus 2. Where we get a from? C. Well, a, yeah. Put c. Mistake, sorry. X to the n minus c to the n is equal to x minus c times x to the n minus 1 plus c times x to the n minus 2 plus c squared x to the n minus 3 plus blah, 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 blah. Space of one more or two more. Let's see. All right, two more. Squeeze it up. C to the n minus 2 times x plus c to the n minus 1. All right, so make a note of that. Write that off. If you multiply both of them, you get it out. So there, you see in this part right here, in this region right here, right in this, you're going to be n terms in there. If the power is n, you're going to have n terms. If the power is 5, you're going to have 5 terms. I can probably show it to you, you know. Use power to be 4. You can just use the 4 terms. Let me use 4 so you can see it. Let's say it was x to the 4 minus c to the 4. You're going to get x minus c. But you could actually prove that thing that does the while ago by polynomial division. But of course it's n terms, so we don't know what n is, but it works for any n. Anyway, so this would have been x to the 3 plus c times x to the 2 plus c squared times x to the 1 plus c to the 3rd power. Let's multiply it out. Multiply all of them by x. You're going to have x to the 4 cx cubed cx squared, sorry, c squared x squared plus, what do I multiply by x? Yeah, so c cube x. Let's double check that. X to the 4 cx cubed cx squared c cube x. Yeah, the powers must always add to 4 plus, all right, sorry, not plus, minus, because multiply by negative c now. Negative cx cubed negative c times that, so that's negative c squared x squared negative c cube x, yes, c cube x, and then minus c to the 4. What cancels now? There's a cx cube here, a cx cube here, there's a c squared x squared here, c squared x squared here, c cube x here, c cube x here. So you see all of it is x to the 4 minus c to the 4. It works for any power. I noticed that right here, remember I said the power was 4, and I said there are 4 terms in this second part. It's going to always happen. If the power is 5, you're going to have 5 terms in the second part. If the power is 7, 7 terms in the second part. If the power is n, the thing underlined at the top is going to have n terms. Later, you're going to see why I mentioned that. Yes, Anthony.
Is this a topic that's taught in college algebra?
Wait, which part? That no. I was just pulling a Dr. Simpson when I mentioned it to my class that early.
Huh?
Because it was when I did it to my class, it was because we were finishing up the course quickly, so I just showed them that extra stuff. But I don't normally teach that. It's not required for college algebra.
Okay, what course is it? What course is it? You might find this appearing in at first.
Well, I don't know. I don't see taught anywhere. Maybe linear algebra. Because I think I've seen something like this in linear algebra. But once again, it's not required. It's just extra stuff. I don't know, to be honest with you.
Okay, it's really cool because difference of two cubes, difference of squares, all that, it could be really handy.
Yeah, you can factor. That's true. That's true. Because in college algebra, always shows difference of cubes. They don't go up to nth power. Right.
Be
That's
very
helpful. Because it's actually when I was doing difference of cubes, I showed them the when the power is n as well.
okay.
Some of them liked it, but some of them, I have people saying, "Sir, why are you showing us this for?" But the majority of them preferred it because a couple of them were nursing students, so they didn't care about that. But the math majors grab it up.
Yeah, man, I would have loved to see this before.
It's helpful. All right, so we're going to prove this thing now. We're going to prove that if the power is x, if the function is x to the n, that when you differentiate it, you're going to get n times x to the n minus 1. So we use the other formula while we're going to use this formula. F prime of x is equal to f limit x tend to c, x to the, what am I talking, f of x minus f of c over x minus c. All right. So remember that thing that I showed you a while ago? You're going to look at it. It's in the book. We're going to be using it now. So if f of x is equal to x to the n, we're going to do substitutions. We're going to get f prime of x to be equal to the limit. Sorry, f prime of c, because the formula has c. Let me see if I can make an adjustment here. F prime of c, c, hopefully c is looking up. That's a c. So f prime of c. So the answer is going to have a c instead of x. So it's going to be limit as x tends to c. F of x is the same f of x, so that's x to the n. F of c, replace x with c, you get c to the n over x minus c. So we're gonna input that thing that we just used a while ago. Put it down here since it needs some space. It's a limit as x tends to c, factored x minus c. So we're gonna have the same things that we had before. So we're gonna start from x to the n minus 1. And you're gonna have c times x to the n minus 2. Oh boy, small writing is hard, n minus 2, yeah, plus c squared. Then you're going to have n minus 3 for the power of x, and so forth and so on. I'm going to jump down to the last two, which will be c to the n minus 2 times x, then plus c to the n minus 1. Sorry for squeezing it up, that's an n minus 1. Right, so c is n minus 2x plus c to the n minus 1. The 1 is kind of falling off the board. Right, see, I put it there. And that's all over x minus c. So of course, x minus c's are going to cancel, leaving us with the limit as x tends to c, the thing that we have in brackets there, which is x to the n minus 1, c, so I'm going to write it properly now. I don't have to squeeze it up as much anymore. C squared x n minus 3 plus, limit these dots, c Cn minus 2 times x. So if I can't see the thing at the top, we can use it down here. Cn minus 1. I still write it bad. Right. So now we can input the c's for the x, because x tending to c, you can replace all the c's, replace all the x's with c. So we're going to have c to the n minus 1 plus c times c to the n minus, I'm not going to write it. I was going to write the answer, but I'm just write it. C times c n minus 2, c squared times c n minus 3 plus dot 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 c n minus 2 times c plus c n minus 1. Now, when you multiply all of those, what are they equal to? What are each of them equal to? Anybody?
Cn to the minus 1.
Agree.
That's right. Well, I mean, she says Cn to the minus 1, but I think she means c to the n minus 1. That's correct. So it's c to the n minus 1 plus c n minus 1 plus c n minus 1. And of course, I get the point. All of my c to the n minus 1 plus blah, 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 blah. But wait, how many of them are there?
Infinite amount.
No, man, I told you how many of them. I told you how many of them are there. I said, remember, I told you it's going to be important later. I mentioned it before, though.
I don't know.
Remember when the power was 4, how many terms were in the second bracket? It's in the paper. It's, well, that's assuming you wrote it down. That's correct, Michaela. There are n of them. I mentioned it, you know. I said it's going to become important later. When we come, and this is where it is important. There are n of these. I'm going to go back and show you again where I told you that. So the answer is n times c to the n minus 1.
Ooh.
Which is the next proof of the power rule. But this time you have to use it. You have to use put a value for x because of the formula. But it's the same thing. If it's not x, then it'll be, if it wasn't c, it would have been the same x to the n minus 1. But anyway, take that off, and I'm going to show you, because you need to remember that, why it is that we know that there are n of them. So Michaela, Lafern, Anthony, when you finish writing, please say so, or just type F or something, so I can know to move on. And any questions you have, you can ask as well. So we're going to prove the product rule next, and I'm going to give you the quotient rule as an assignment, which is due tomorrow. So Anthony is finished. Lafern and Michaela, whenever you're ready, just let me know as well. Not rushing you, just telling you to let me know. Otherwise, I'll just be sitting here not knowing what you're doing. Okay, Lafern? Lafern, I didn't see you at church on Sunday. I mean, Saturday.
Sir, I didn't see you because I was there. I didn't see
So
you.
you're saying that I was there? Is that what you're saying?
What you said, sir?
You're saying that I wasn't there?
You No, sir, you weren't there, because if you were there, I would have seen you. You must have watched you watch it online?
No, I didn't even watch it online. I watched something else. Because I was first I woke up. What time I woke up? I think I woke up 9:58 or something like that. And I get to church late most of the time just because I go to McPatrick first and then I head to your church. But then we never go to church after 11:30, no, sir. Not into that. Look too bad. So I didn't bother to come. Wait, Michaela's here? Michaela, you finished it? What? Oh, okay. You're here listening to me, I'll friend. All right. Product rule now. Oh, before I go to product rule, the thing I mentioned a while ago. You see, if you have x to the n minus anything, a or p or q or a, I think we will see a while ago, but anyway, a, you're going to have x minus a. The number of terms that appear in here will be n terms. You're going to have x to the n minus 1, whoops, minus 1, plus a times x to the n minus 2, plus blah, 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 blah. You know, list of things I wrote a while ago. The last one is going to be a to the n minus 1. N minus 1. What is wrong with this n? Yeah. There are n terms in here. See a while ago I showed you with x to the 4 minus something to the 4, c to the 4. There were 4 terms occurring inside here. If it's x to the 5 minus n c to the 5, there are going to be 5 terms in the second bracket. And since there's x to the n minus a to the n, there are going to be n terms inside here as well. So n terms. So that's how a while ago we knew that was n times c to the n minus 1. Because there were n terms, and all of them when you multiply, we're going to get c to the n minus 1. So there are n times c to the n minus 1. All right. Product rule, and then we are done. Because of the quotient rule to prove on your own. How should I write this? All right, let me write it like this. We know that if you have f of x times g of x, let's call it y is equal to a function times a function. Then the derivative of y is equal to f dash of x times g of x plus f of x times g dash of x. By dash I mean derivative. So we want to prove this now. I want to prove this formula right here. That the derivative of a product of two functions is equal to that thing by using limits. All along you've been given those things and you accept them as gospel, but now we're going to prove them. All right, so let's start by saying, all right, so since it's right here, or how should I write it? All right, I'm writing like this. So f of x, g of x, the derivative of all of this is equal to the limit as h tends to 0 of f of x plus h. Oh, should I written the formula? But you know the formula already. Remember, it's f of x plus h minus f of x over h. So I'm going to replace, in both functions, I'm going to replace the x's with x plus h. So it's f of x plus h, g of x plus h, because a composite function, you know, minus f of x times g of x, all over h. Now, this is a tough part. Well, I wouldn't say tough, but the trick to solving it is to know the substitution. You're going to add and subtract something. So it's going to be limit as f of x times, oh sorry, f of x plus h, beg pardon, g of x plus h. So here's the term you're going to subtract and add in now. You're going to subtract f of x plus h times g of x. You could also have used f of x times g of x plus h. Both of them give the same result. Remember, we're not creating anything new, we're adding and subtracting something. So whatever you subtract, you have to add. So we have to add it back, f of x plus h times g of x. And that's still have the f of x, g of x at the end. draw my line. So it's all over H. Okay. So of course, once we add and subtract something, you know that the next step is going to be factoring. Each time we've ever done that, we've always factored afterwards. So I'm going to factor. I'm not going to skip a step. Just people normally skip it, but I'm going to make sure you guys see it. So in that first part here, you see that there are f of x plus h in both terms. The thing that we just added, the first two, f of x plus h, g of x plus h, then you have f of x plus h, g of x. Both of them have an f of x plus h. I'm going to factor it out. So that leaves f of x plus h times g of x plus h minus g of x. And the same thing can be done in the next step. We can also factor out g of x, which occurs twice. You see g of x in both of them, take it out. So g of x times f of x plus h. Sometimes bracket is so hard to write. You get that one line. Times, minus f of x, not times. And it's all over h. All right. So we can actually split those two. All right, we can split those two right here to get two separate limits. That's the step I was talking about, not skipping. Could have skipped to this a while ago, but I didn't want to confuse you. So we have the limit f of x plus h times g of x plus h minus g of x all over h plus the limit as h tends to 0, g of x times f of x plus h minus f of x all over h. Now, if you look at that, you realize that there is a in the second limit you can factor g of x, and the first limit there's nothing that can be factored out. But you don't have to factor out anything anyway. We can just simply apply the limit as we know it. But look at this. If you split them properly now, completely split them, you realize something. Like put this as one limit. As you can see, the f of x plus h is multiplying everything. Put it as one limit. And then put the next part. This is a times. The next part right here. You should be able to figure out which limit that is. This is now g of x plus h minus g of x over h plus, split this one again, limit h to 0. Could take g of x out because there's no h, but I'll just leave it there. Times the limit h tends to 0, f of x plus h minus f of x all over h. So as h tends to 0, we're going to do them step by step now. Look at the first limit. There are 4 of them. See, limit, 4 limits. For the first limit, when h is equal to 0, 0 plus x is just x, so it's just f of x. Look at that second limit. So f of x, that'll look worse now. This one line. Use black. F of x. Yeah, hopefully you can see that x. The second limit, the one multiplying it, what is that equal to? The limit as g of x plus h minus g of x over h as h is 0. What is that limit equal to? Hello?
Sir, is it?
Maybe.
When we undefine?
No, man.
As
what happens to this limit right here? No. This part here. Right there, probably a seat. the limit as h is 0, g of x plus h minus g of x over h.
Well, okay.
All right, replace the g with f and see if I can figure it out. And then put the
Sir, is it g prime of x?
That's exactly what it is. It's just the formula come back, you know. Just that instead of having f, you have g. You guys realize it now, Anthony and Michaela? Pardon my bad writing. Maybe it's my bad writing too, yeah. But it's the same definition I gave you before for limit. I mean for derivative.
Like that. Okay. Gotcha.
See it now? Okay.
Yeah. I was
and for the
where h is.
yeah, that's the problem. You can't do that yet because you didn't get 0, 0. All right, so for the second one, you see the limit of g of x as h tends to 0 is just g of x because there's no h there. So it's just simply g of x. As for the second part, it's quite obvious that's just the definition of a derivative again, f of x. So it's times f prime of x. And that, my dear friends, is the proof of the product rule. Nice and pretty. Well, nice and ugly. If it was on the whiteboard, it would look much better than that. I'm sorry for that, but hopefully you understand it. Any questions?
So the limit concept actually is used to prove calculus definitions.
Yeah, remember calculus is limited. You know, okay, all the rules that you see in calculus,
yeah,
all derivative rules, product rule, integration rules, all of them come from limits. Remember, calculus is the study of limits. You know, it's just that they put in a more concise form where it's easier to apply. But all of it comes from this.
Oh.
Wow. So read analysis goes in depth and show you how to prove stuff. And like, if I had more time, if actually, I think if I were actually in class, would have gone further. But the online thing is really tough for me. So I kind of picked out the most important topics for the syllabus. Because I'll actually would have proven all of them. I'd have proven the quotient rule, product rule, chain rule, for rule. The only one we're not going to prove right now is the chain rule, though, because you need to prove a quotient rule for your assignment. Speaking of which, let me give you a hint. You see that same substitution I made at the top here? Because if you don't do this, you can't do it. You're going to make it again at the quotient rule. Somewhere. You need to figure out where. When you get stuck, make that substitution. Wait, is it the same substitution? No, it's similar. A similar substitution you're going to make. Not the same. I won't tell you exactly what, but all right, let me tell you. You see where you have the f of x plus h, remove the h. You're going to make the same substitution without the h. So that thing I circle while you're going to make the same substitution somewhere without the h. In proving the quotient rule. I need to send that to Jermaine. Wait, you guys talk with Jermaine, right? I have his number.
I have his number.
All right, please let him know that it's an assignment because I want to give one more graded assignment. I was going to put more in it, but I think that should be enough. Prove the quotient rule. So make sure there's no mistakes now, because since this is just one question, I'm going to look for every single mistake I can find when I'm marking it.
And this is due when? Wednesday, sir?
Tomorrow. One question.
Why so quick?
If you want,
Sir,
Wednesday, I can give you some more.
Tomorrow.
What? Why you want to take so long?
Sir, we have other things doing, you know?
Yeah.
Let me put on 2 more questions and give it.
No, sir. And if you give us 2 more questions, you have to do the end of this week.
Mercy.
Okay, I'm putting on 4 more to make it do this.
Tomorrow. Get it tomorrow. What do you want tomorrow?
Yeah, go ahead. I mean, we don't have a class Wednesday, so it's fine.
So we don't have any class Wednesday?
No, this was the last thing to do. proof of these.
Okay. All right. So we get basically this is we get another section, all right?
Yeah, that's what I was going to ask you as well. I mentioned it to Michaela at the start of the class before you guys came. If
Okay.
you want to test Wednesday or Monday.
Monday.
Monday, okay. It's going to be, so the last test stopped at what I'll have to do is give you some practice questions so you can know what to expect, because with this course you're probably unsure about what kind of questions you can get. What was I saying? The last test, I'm trying to find it on my computer.
So, sir, why you don't have a revision class this Wednesday?
What year to revise?
To prepare us for our test on Monday.
That's what you're going to do. You're going to revise it, and you need time to revise. Why you want to make me revise with you? I'm not doing a test like that. The last test stopped at the limit, proof of the limit. What can I test you on now? I didn't test you on, sir. Alright, tell you what. I'll send you some questions, practice questions. If you can't manage them, you let me know and I can come to the revision class. Alright?
Okay, sir.
Tell you what though, my head body no. So when I send you the question, remind me to send you the questions in the first place. Send me a reminder. I don't have a, huh?
Send a question. You're gonna send a. You want us to remind you when?
At 5 p.m. because I normally have a class at 5, but that class finished last week. Finite maths, their class finished. So send me a reminder at 5 p.m. by email or you have my number. Text me.
Today, tomorrow.
Yeah, today.
Okay.
So I can send you the questions. You can try going through them. If you can't manage them, then Wednesday you can let me know by tomorrow evening or something.
Okay.
So I can do the revision Wednesday.
No problem.
I can just go through the questions. Make sense?
Yeah, man.
All right. So the quotient rule, prove it in the people, and it's due tomorrow. The test is Monday. Hopefully Jermaine watches this in time to hear out some information. But please tell him to prove the quotient rule. He might have to watch this to understand what to do. So tell him to watch it to understand what to do.
Sorry. Did you say when tomorrow, sir?
Anytime tomorrow, as long as it doesn't go into Thursday. As reference 11:59.
As long as it doesn't go in
tomorrow. As long as it doesn't come in Wednesday, meaning if you send it in 12:01 Wednesday, I'll be taking off marks because I get the whole day today to do it.
Okay, no problem. No problem.
And what my students have a tendency, if I tell them 3 o'clock, they send stuff 3 o'clock. Not you guys know, but my other class. If I give them extra time, 20 more minutes, they still send it right after. If I give them 30 more minutes, they send it right after again. So I start marking them really hard for it. They're just trying to get extra time no matter what. You guys, I know your course was rough, so you take it as much time as you could, but I just took off like 5 marks and 3 marks for you guys. 5%. That's why Michaela beat Lafern, in the test, because Lafern beat her by 2% and Lafern lose 5%, so Michaela beat her in the end. But you guys did well, everybody get 80s. I remember when I was doing this course at UWI, that was not the case. No. The highest was like 72. I remember because they got beaten by 1% in the first test. You guys did pretty well. Maybe it's because of the online thing, I don't know. Make it better for you. Probably should thank God for that. Because this course is normally very tough. So I'm happy to see your grades.
Okay. We can do. We have a do-over, sir.
For what? The same first test?
Yeah.
You want more than 80 odd? Very not easy.
I didn't get 80 yet, sir.
Oh, I thought you did.
I got 80.
I know I'm going to charge for the over, but I don't want to do over this course. I don't want to do over this test. I don't even want to pay for it.
I just 4 persons.
But then no want to do over. You want it? Let me go see what you get.
Ask Lafern.
Lafern don't want to do over, I can tell you that. Good. Let me ask her. You want to do it over Lafern?
Sir, I would prefer another chance to get a higher grade.
You're not saying that isn't that doable, Lafern? What kind of fancy way you're saying it? Oh boy.
But sir, sir.
Yeah.
when you add our bonus marks, that should take us up to, yeah, 2 bonus mark you give me.
I do? Let me check. I didn't know I had bonus.
Is one is what? 3 you
I don't
gave
have no
me.
bonus mark written down here. Oh, yes, I
7.
do. We have 7 bonus marks, friend. That's 4. I didn't remember that. So you don't need to do over then. I can just add it on, right?
Yeah, but that should, how much that gonna
No,
carry
you
me?
have 7. You have 7, so you're still not gonna reach the
Huh?
big grade we want, but
You say
carry it
what?
further up. I say you have 7 bonus marks.
It's
And
not
that's already
7.
4. I said me have written down here.
How come
Going
it's
by what I wrote. I don't know. How much you expect to have? 20?
no? It's twice. No, it's twice I got bonus marks.
Yeah, one is 4 and one is 3.
It's,
Based on the complexity of the question that you get the bonus marks now. So some questions are 2 marks, some 3, some 4, some 5. And there are very hard questions that you get 10 bonus marks.
okay.
But those are rare.
I thought it was
So
5.
if your first bonus mark was 4, your second was 3, that friend's only bonus mark is 4. And Michaela
Okay.
is always quiet, so she didn't get any. The only bonus mark my friend Michaela could have gotten was one that she answered with N. And that wasn't really a bonus mark question because I'd mentioned it. Just that you guys didn't hear or forgot or something.
Wow.
Oh wait, why am I recording this?